So hello everyone. I'm Robert Petit. I'll be doing I'm gonna try and kind of get through this quickly. One, because it's the end of the day and I have a way of just dragging things along. So title is Deeper Dives, Workflows, and Bactopia. Um, Quick overview. We'll do a quick recap of the day and then deeper dive into a few topics and then Bactopia and a final recap. Yeah, I think Andrea and Anna really slammed y'all today. We talked about Docker, Singularity, SnakeMake, the workflows, Nextflow, all sorts of Conda. That is a lot to digest in one day, and I really want to commend everybody who took the time and effort to do that. So great job. So I wanted to go a little bit deeper into a few of those topics to, pile some more stuff onto y'all. The first is Bioconda. Bioconda is, I think, a very, very valuable resource for bioinformatics these days. It's truly community driven. Right. The last I checked, there was more than 1,300 people who had contributed in some shape or form to the Bioconda repository. It really makes bioinformatics accessible. No longer do you have to do the whole, sudo make and sudo apt-get install. It's just conda install this and conda create this environment. And if something breaks, you just nuke it and start it back up. But I think another important thing that comes out of Bioconda is the downstream containerization of every tool in Bioconda. So every recipe that gets submitted and accepted into Bioconda gets a Docker container created by Biocontainers. And then the Galaxy project also creates a Singularity image from those Docker containers. So you have these basically 4,000-ish recipes on Bioconda, so 4,000-ish Docker images and Singularity, or Docker containers and Singularity images. If you're ever interested in, you made a tool and want to put it on Bioconda, don't hesitate to reach out to me or the Bioconda team. There's a bunch of people willing to help get it out there, and it really helps people to use your tool. So yeah, Bioconda is a great resource for the community, and I'm happy to be a part of it. Another group that we should maybe take some time to go peek at is the NF Core group, because they've really been pushing the limits of Nextflow here these last few years. This is another community effort to collect and curate Nextflow pipelines. So I think the last I checked, they have a thriving Slack community of more than 2,400 users, and similar to Bioconda, more than 1,000 people have contributed to, in some shape or form, to their GitHub repositories. And I think that's kind of cool. It currently includes 58 high quality bioinformatic pipelines, and these range from a behemoth RNA-seq pipeline. That's kind of my go-to pipeline to see the latest and greatest in Nextflow. There's the metagenomics assembled genome pipeline, the MAG, BACMAP, if you want to take your FASTQs and quickly create a phylogeny. And yeah, there's plenty more that ranging from, there's even one that is just image analysis for, I want to say it was cancer. So they basically made a workflow to analyze images and put together a final result. They have numerous standardized guidelines for developers, and while you don't have to take what they give and expect to put it on NF Core, a lot of their guidelines are just good practices for Nextflow, good practices for just software development in general as well. If you do go the route of trying to get a workflow on NF Core, they have a very thorough review process, which allows them to produce pretty robust pipelines. And if you're interested in maybe learning some more about Nextflow, they have a hackathon next month, March 16th through the 18th. I've been a part of the last two, and the level of Nextflow expertise ranges from novices to like extreme experts. So, and one thing they did the last hackathon is they did a paired programming type thing, or a mentorship type setup, where someone who felt comfortable with Nextflow could help out individuals who wanted to learn more about DSL2 and all things Nextflow. And I thought that was kind of cool. So yeah, I would definitely check that out if you're interested in taking Nextflow a little bit further, because it's a great learning experience. But one of the things that Andrea highlighted too is this ability, like the one thing that makes DSL2 and SnakeMake wrappers really great, and Nabil mentioned it too, you could just, these modules are plug and play. Like if I make one, I can pass it to you, and theoretically you can integrate it into your workflow as well. And so there are a few repositories to kind of aggregate these into a curated set of for Nextflow modules. There's the NF Core modules repository, which has 200 plus DSL2 modules readily available, and you can import those into your Nextflow. And they have a tool set that allows you to easily import these at the command line. And once you import them, you can either use them directly or modify them to fit your needs. Similarly, SnakeMake has SnakeMake wrappers, which again is 100 plus wrappers of SnakeMake workflows that you can bring in to your SnakeMake pipeline, which I think that's pretty cool, because pretty much we're all going to run Proca or Shovel, FastP in very similar ways, and being able to just go grab this Shovel module from NF Core modules and do my thing is pretty awesome. So it really allows you to conduct rapid prototyping, and that saves a lot of time. And if you like, I think Nabil mentioned earlier, where sometimes you just need get a quick result. If you become efficient at importing these modules, you can have that, FastP, Andreas too, where you could go from FastQ to a phylogenetic tree pretty quickly. And then, if you start doing it more and more, you can decide whether to fully wrap it. But yeah, I want to get into some workflows and analyzing bacterial genomes. I think this is one of those slides that sums up all of bacterial genomics in 4 images. It's pretty standard. You grow your bacteria, extract the DNA. Sometimes you don't even grow the bacteria, you just take from the directly. And then you sequence the DNA. You're given these FASTQ files, and then you want to generate some results. Oftentimes, it's this generating the results that becomes, how do I get there, and what options are available for analysis? And we've kind of gone through these throughout the day. You can, just play with the command line, conda install FastP and clean up your reads, and conda install Shovel and assemble the reads. And you could just do that at the command line, which is very useful for one-off, very quick answers. Like someone just says, hey, I just sequenced this. Can you tell me what the serotype is? And you're like, that's fine, but we can do a quick and dirty command, and then here you go. And then they may never want it again. Eventually you start using them more often. You may toss those commands into a bash script and it gets the job done. But I hope after going through this workshop, you're kind of thinking, we could probably do better by using a workflow manager. And so the next step would be, hey, I'm repeating this a lot. How much can I offload to a workflow manager? And so you can create your own workflow with any workflow manager. I think it's important to state that, and it's been stated previous multiple times today, like choose a workflow manager that you're comfortable with. I think SnakeMake and Nextflow are great. So I'm just more comfortable with Nextflow. So I chose Nextflow. But this could be quite time consuming, making your own new workflow from scratch. But you do have the benefit that you're in complete control. So you can configure it as specific as you want to your needs. And the final kind of step in this is you can use an existing workflow. This will save time. It's likely going to be a little bit standardized just because it's being used by more people, so that it's kind of settled on a few analyses. But I think you will. There are some potential obstacles whenever it comes to getting something set up and running. Like we've mentioned it a few times today, that whole it works on my system bit, and containerization helps get around that, but there's still that initial setup that can be troublesome. So there's all sorts of things to keep in mind, and many ways to analyzing your samples. But I'm a bit biased, so I would hope you going to try and persuade you to consider using existing workflows. And yeah, your first question may be, but which one should I consider? And because there's so many, and so again, I'm a bit biased, but I hope you would consider using Bactopia. And I hope after the next few slides, I can persuade you on why. So all these tools that you see are pretty common, kind of standard use in the the bacterial genomics space right now. And Bactopia is a pipeline for the complete analysis of your bacterial genomes, and currently includes more than 100 tools. It's built here recently, I think less than 6 months or so. It's been completely converted to DSL2, which is so nice. Just being able to, the modularity is a huge weight off my back with Bactopia. And so yeah, it's built completely using Nextflow DSL2, and it's available for Bioconda, so you can just Conda install Bactopia. I would definitely recommend using Mamba to create a new environment for Bactopia. It allows inputs from pretty much anywhere, and that's kind of building off of having Nextflow on the back end. So you can bring data from cloud storage buckets like AWS or Google or Microsoft, or your local file systems that you may have access to on your HPC or your laptop. An important one that I tend to use public data a lot, so I wanted to make sure you could download from SRA and ENA and the assembly database directly from Bactopia. And it supports Illumina or nanopore FastQs. And if you want to do hybrid assemblies, you can. It includes all your kind of standard steps, your QC, assembly, annotation, kind of all the things you're going to want to do when you get a bacterial genome, and helps to answer most of the questions that you might want up front before you start digging deeper. It includes multiple helper commands. So these aren't Nextflow commands, but they're commands to kind of help supplement your analysis. There's the Bactopia citations command. I think this is one of my more, this one will always stay. And I was glad I didn't get any pushback on putting this table of 100 different tools in our paper in the main text. But yeah, this Bactopia citations will print out all the citations for all the tools that Bactopia uses. And you can check out the acknowledgements link to see all of them. I think it's just important to acknowledge all the tools that Bactopia uses, just because without all these tools, there would be no need for Bactopia. There's the Bactopia datasets command, which will download and set up a bunch of useful data sets to supplement your analysis, and I'll have a slide on what specifically a download. The Bactopia download command will pre-build your Conda, Docker, and Singularity environments for all the steps in Bactopia. This is especially important with Conda because Conda does not like to build environments in parallel. And by default, Nextflow will attempt to build environments in parallel. And so what happens is there will be lock files, and one environment will be being built, another one will start and try to access this lock file, and then it just explodes. So to circumvent that, I created this Bactopia download step. There's the Bactopia prepare command, which will create a file of file names. And what that does is allow you to process as many as, or as few as one sample to as many as thousands, hundreds of thousands, as many as you want to fit in this file. And you can just feed that file directly to Nextflow. And the Bactopia search, again, because I like using public data, this will generate a list of SRA or ENA accessions that you can then import directly into your analysis. So example would be, we had this study that we want to include in our analysis, a bio project or something. You can include all of those samples in your analysis. Now, the Bactopia datasets supplements your analyses. It includes datasets that are really helpful to bring more to the table. It includes sketches for RefSeq and GenBank, reference genomes, custom proteins for annotation, MLST schemas, Ariba datasets, genes, proteins, primers, you name it, you can throw it in there. Here's another fun thing about Bactopia. There's these Bactopia tools, which are completely separate, independent workflows that use the outputs of Bactopia to run additional analyses, such as like pangenome analyses and core genome phylogenies. With DSL2, I've broken them into two types, modules and sub-workflows. Modules are a single tool. Workflow, it basically just runs one tool, whereas sub-workflows connect multiple modules together. And you can think something like run Proca to get the GFS, feed it to Pirate, feed that core genome alignment to IQ tree to create a phylogeny. And I've frameworked this so I can easily add new tools to this. And yes, and that's all possible because of Nextflow DSL2. Yeah, so because of DSL2, every Bactopia tool can be reused anywhere. I won't go through the list of all these tools, but at the moment there are 22 additional tools to the main Bactopia pipeline. These include species-specific tools, pangenome, phylogeny, and annotation. And they're all built using DSL2 modules. I really want to highlight, because of DSL2, every Bactopia tool, which is a DSL2 module, can be reused. So to demonstrate this, Bactopia includes at least 10 species-specific sub-workflows, and these are like serotyping for E. coli or MEC, MRSA, and Staph aureus. And but sometimes you don't know the species, and so I had the question, like, I wanted to do this a long time ago, but DSL1 made it very hard. But could I create a new workflow to be used to automatically execute these other species-specific workflows based on some sort of distance? And that created Merlin, which stands for the Minware Assisted Species-Specific Bactopia Tool Selection. And if you look at the very bottom of the slide, you'll see where I got that from. But basically, it uses MASH sketches to kind of determine this sample is close enough to E. coli that I think you should run Ectyper. Or this sample is close enough to Staph aureus, I think you should run Aggravate. But yeah, it includes, and it uses the RefSeq MASH sketch that's downloaded by Bactopia dataset. So I'm reusing data that you presumably would have already downloaded. It currently includes a number of species-specific analyses. And the cool thing about DSL2 is if there's another organism that has a tool that we want to add, we just add it in. No sort of reworking the full pipeline. It's as simple as adding that one line with the module and feeding it to the inputs. But what this kind of demonstrates is module reuse in condition-based execution, which is kind of cool in DSL2, where you could say, hey, that condition if E. coli, run E. coli tools. Yeah, the name was created with this acronym Python package, which is a fun little thing to create acronyms. When I saw Merlin pop up, I was like, we're going with that. Some other things that Bactopia is doing is it's doing a lot of testing, and that helps keep things running. And these tests were adapted from the NF Core modules repository. Basically, every step is tested to make sure it's still producing the expected outputs. I think at the last time I checked, it was more than 10,000 output files, which seems kind of extreme, but some of those programs just spit out a lot of files. And it's been all automated through GitHub Actions. And this is kind of like getting outside the realm of workflows, but it is kind of nice to have this whole CI on the back end, this continuous integration where I can submit changes to the workflow and determine whether it's still working or not. And on more than one occasion, it has saved my butt, which is very nice. And I think one thing that's awesome is by using Nextflow, and this is not Nextflow in particular, most workflow managers now will do this for you. But it basically, by using a workflow manager such as Nextflow, I'm pretty much platform independent. Are there hiccups getting set up on some platforms? Yes. But once you get that initial configuration set up, you're off to the races. You can run it on, you can use Conda, Docker, Singularity, any of the cloud platforms. Nextflow Tower, we didn't really talk about, but I'd recommend you check that out. It's kind of a fun way to launch Nextflow pipelines from a web page. But all you got to do is change this dash profile to your platform of choice, and you can set those up to customize it to your system. And yeah, SnakeMake and Cromwell offer the same sort of portability, which is, had I not used a workflow manager, that would have been a huge pain in the butt because you would have to work out the whole back end for each one of these systems. And I think we're in a phase where, or a time where it's let the workflow manager handle that. And another thing that Bactopia has helped out with is helping to contribute back to the community. Bactopia has helped me get really involved in Bioconda. One, I made a rule when I created Bactopia, a self-imposed rule. I'll only use tools that are available on Bioconda. But that won't stop me from using it, because basically if it's not on Bioconda, I'll work on getting it submitted. And through this process, I've helped review over 1,000 Bioconda pull requests. So please don't, if you're interested in getting something on Bioconda, don't hesitate to reach out, and I'm happy to help. Similarly with Bactopia version 2, with the transition to DSL2 and this ability to make modules reusable by anybody who wants to use it, I thought it would be great to require that all Bactopia tools originate from NF Core modules. So basically, you can run it on Bactopia, but you can also import it from NF Core modules. So that way, you don't have to use Bactopia. You can use some of the modules that Bactopia uses. And yeah, I think that's super awesome because it basically allows you to go on and create your own workflows. Unfortunately, NF Core modules lack bacterial tools or modules for the types of things we want to run. And as part of that, I've become engrossed in that, and so I'm submitting as many modules as I can to cover all our bases. And I've submitted about 25 there, and they're a great group to work with. So I highly recommend checking out Bioconda and NF Core. Also, as you know, as I find things have stopped working in Bactopia, it may be a simple, this hard-coded HTML link change in this program. And we could just submit a quick pull request to that tool. And some of the tools include that I've, because of breaks that I've found in Bactopia, help resolve the issues downstream. Include Bowtie and Proca and Shovel. Pirate, all those. So I kind of like this idea that I'm not just consuming what's out there, I'm helping to give back. So just a quick wrap up. Bactopia is completely DSL2. If you're getting into Nextflow, I would try to ignore as much DSL1 as you can and just jump straight into DSL2. I was hesitant at first, but now I'm kind of, I'm kind of grumpy with myself for taking so long to make the conversion. And yeah, so Bactopia follows the NF Core standards and practices, which it's not an NF Core pipeline, official pipeline, but I think following their practices and standards to some degree, it has really made it easier to maintain. It's for your complete analysis of bacterial genomes, whether it's Illumina or Nanopore. I still have a lot I want to put into it, including standard reports, many more Bactopia tools, and example outputs from each of these tools. And yeah, you can use any of these modules in your own workflows. So I think that's pretty cool that, you don't have to use Bactopia. You can just take the workflows and run, which is pretty awesome. And that's the great thing about DSL2. There is a tutorial available if you want to give it a go. Don't hesitate to reach out if there's any issues. I'm always looking for feedback. So circling back to this image, I hope the next time you're kind of in that middle ground, like, what do I do with these? Maybe you'll give Bactopia a try and let me know if there's something missing or you have any feedback on it. Final slide. Yeah, we threw a lot at you, and I just threw even more at you. So Anna mentioned biocontainers earlier, which is a great repository for bioinformatic containers, and the Galaxy project, which aside from their Galaxy platform, they do a bunch for the community, which the bioinformatic community, which is pretty great. And if you're going to get into Nextflow, it's a great time to check out the NF Core and maybe join their Slack group for some. It's not Nextflow specific help, but they're more than willing to kind of give you some help on Nextflow. And yeah, Bactopia Merlin. With that, I include these slides should be in the Discord, so you can click all the links. And I tried to make it as informational and kind of push you to other avenues as you get into workflows, which, as Andrea mentioned, is not an easy. That learning curve is not fun, but once you get over it, it's very rewarding.
All right, thank you, Robert. If you enjoyed that, give a reaction on the, there you go, a few people giving the clap thing, or post a message in the Bactopia channel on the Discord as well. Well, we're not done yet. It's time for the discussion panel. If you have any questions, drop it in the Bactopia channel on the Discord as well. One of the two take homes for me is how long did you spend on it's 10 years, isn't it, Rob? Let's be honest.
Yeah, so
this is
if we want to get into this, it was an evolution. Bactopia is not the first iteration. Like it was never Bactopia until 2018-ish. Prior to that, it was Staphopia.
That's still from the before times, right? So that's a long time ago. So I mean, if I've put the link to the GitHub in the Bactopia channel, please go have a look at it, because even I think the platform, the Bactopia as a tool, it's very easy to install. It's very easy to just get up and running with stuff, get data sets down and start running analyses. Sort of your first pass of what you would want to interrogate, what Rob was saying, it's really, really good. But even if you don't, you just for the sake of it want to write your own thing, there's a lot of practices in there. I mean, someone was asking, how do I effectively collect version numbers for tools in Nextflow, right? That was a question from before. Bactopia does it. It has an implementation. I put a screen cap of the code there. It's very clearly written and commented, so that you can look at and draw some inspiration of how you'd actually do it.
And that's one of the NF core practices that from the modules repo that I kind of adapted to fit Bactopia as well.
Yeah, and also admittedly, like I do flag all of Rob's modules. If he has it, I first copy paste that, and then I go and mush it up to do whatever I want for workflows I'm working on as well. So just that resource is there. There's a few questions coming in on Bactopia. Does Bactopia work for metagenomes, or does it only work on a few species or genera?
It's really isolate based, any species or genera, but at the moment, like isolate based. So you sequence a single isolate. I imagine we could potentially add some metagenomic stuff. That's Bactopia tends to include stuff that I'm doing on a daily basis, and we are starting to get into some metagenomic stuff. So I don't know, maybe it will come in soon.
I think Andrea can speak more to metagenomes. In my experience, metagenomic analysis is a bit more nebulous with what people want to get out as a result. There's no equivalent of like, oh, here's a salmonella, I want Sarovar prediction. There isn't like a metagenome suite of tools that you just want to run. Anything coming up for bacteriophage? Oh, this is definitely, I think, Andre, you have to chip in here. Metagenomes and bacteriophage in the Nextflow space. You can stop sharing the screen, Rob.
Oh yeah, sorry.
It's all right.
So in terms of bacteriophages in metagenomes, I'm working with some collaborators on a...
Sorry, I didn't mean in metagenomes. I meant just in the Bactopia assembly pipeline, if there was anything phage specific.
There are a few tools that I'm planning to add. I think one was Figaro. But if you have any recommendations, don't hesitate to create a GitHub issue that says, hey, I think you should include this tool. I personally just haven't done much on the bacteriophages, so I'm not too up to date on the tools for bacteriophages.
Okay. Yeah, and also I'll point you to Andre is working on different things as well in that space. So maybe we'll see a phage or metagenome pipelines. Andre, did you want to add to that?
No, there is a pipeline that should be released soon for the profiling of metagenomes. So using different miners and trying to make a nice report. But yes, for isolates, the biggest challenge is the difference of the input. So library, basically the biggest challenge is to clean the input for downstream analysis, and the source of contaminations are different. So at the moment, because they are very small, and so you don't really need the full cluster to analyze a phage, manual analysis is still quite a thing, because there are so different issues that automatically detect them is not that easy. Because then a lot of phages are circular, and you want to rotate them to match the reference, but also in terms of reference, It's not like bacteria where the taxonomy is more definite. It's very likely that you're going to have quite different phages from what you can find in the public databases. So I stick with the expert like Evelyn in our institute, and apparently it's very common to to work in a more manual fashion.
Yeah, so metagenomes, Rob might get around to something, Andrea might get around to something, bacteriophage is a bit more nebulous. And hey, maybe that's scope for collaboration or something. I think that does need to be a bit more fundamental science to really, work out better tools before we start just pushing it through pipelines. I agree with that.
NF4 has a pipeline for the assembly of metagenomes. So if you want to create mags, I think it's good to give a try to NF4 mag. And I'm not surprised that if compared with all the other applications, the metagenomics area is lagging behind also in NF4, because as Nabil said, the applications are different, the tools are evolving, and no one is really so good that you can settle with that. So probably it's something that is going to come quite soon, because there is a lot of interest. So
yeah, I think that's something we can, because we're sort of running into the discussion panel segment now as well. So we might take a few more questions on Bactopia specifically and just jump straight into that. But part of the reason why we're only now talking about workflows more and more in this sort of standardization is because the underlying tools and the underlying analyses have been worked out. There is a train of thought that we approach certain data sets with. And if you can't hammer that out, if you're like, well, I want to do this, but then if that happens, I want to do that, and I want to do that, then it's too nebulous for these sort of engines. You wind up writing a lot of conditional logic to try and cater for that, and this doesn't really work. If you have to keep going back and tweaking parameters and so on, you find that it becomes more of an interactive process, much like how genome assembly and even working with culture, like sequence data from culture, used to be 10 years ago. If anyone was around then, I was just starting back then. Maybe people were around then. It was pretty hands-on with it. Any other questions on